Welcome everybody to a new section of geometry, new chapter, chapter 7. We're going to be getting into similarity, but before we do, we're going to talk about some ratios and proportions. So President's Day is coming up, so that's Washington, D.C., if you didn't know. Okay, what is a ratio? That's the first thing we're here to talk about. A ratio is a comparison of two things. Okay, and usually they're obviously two different things. For example, you gotta have a ratio of boys to girls in your classroom. That's probably the easiest one to compare. So let's say you have 20 students in your class, and we have 12 of them are boys, and then 8 would be girls. Had to do some quick math in my head. So 12 boys, 8 girls, 20 students total. So there's different ways we can notate that. We could say that there's a ratio of from boys to girls, and it has to be given what you're comparing. So boys to girls, we could say that it is 12 to 8. So you could use a colon like that. You can also use a fraction. So we could have boys to girls, okay, and then we could have 12 to 8 like that. So a couple different ways to compare two different things in a ratio, a couple different ways to write it. Those are some of the most common. I like the fraction. Some people like seeing this. When you get like model cars or maps, usually it's written like this with the colon. So just be mindful of that. That's what it means. So let's get into our first example. The British-made Noble M600 is a sports car that is 172 inches long. Or, now if you wanted to convert this to feet, all you would need to do is do 172 divided by 12, and I think it's 14.3. It is 14.33 feet, just to give you a scale of how big it is. A toy replica is 9.55 inches in length. This is an actual problem, by the way. The actual scale, actual car is 172 inches. A toy replica is 9.55 inches in length. That's pretty big. Approximately, what is the ratio of the length of the toy to the length of the actual car? So what are we comparing? We are comparing the toy to the actual car. Or if you want it in ratio, fraction form, we have toy to car written like that. Okay. So now we need the length. So we're comparing the lengths of these two things. The length. What are the lengths of each item here? So we have the toy is 9.55 inches. That's the symbol for inches. And then we have the actual car is 172 inches. No one would actually say that their car, oh, I have a 172-inch car. Usually they'd refer to it in feet. That's just a little bit easier to reference. But it makes this problem easier to mention it in inches because you have to have, let me write this down, you have to have the same units in the comparison. Okay, so here we're converting inches, here we're converting inches, not converting, but we have inches, and then we have both of those there. Now, it's not really a good practice to leave a decimal in a fraction like that. So what we should be doing here is we need to convert this to have whole numbers. The way to do that is to divide both the top and bottom by 9.55. to get that top number to be 1, and hopefully the bottom number will look a lot better. And as we do that, we do 9.5 divided by 9.55. We get 1, of course, and then we do 172 divided by 9.55, and we get, I'm going to round it a little bit, 18. All right, so there's our final answer. There's the ratio, 1 to 18. Okay, what does that mean? That means for every inch that the toy is long, the car is 18 inches long. Okay, so for every 1 inch of the toy, we're going to have 18 inches of the car, and it's probably even longer than that. But just to give you a scale, okay, toy, actually it's probably longer. Okay, and I just, essentially if I lined up 18 of those little lines, that would give us a scale. That's about right. That probably is about 18. So every 1 inch, the car is 18 inches long, okay? And that's how you figure that out. And that's kind of useful information. That gives people a sense of scale. So you see a lot of statistics companies, publications, newspapers, advertisements use ratios to help the reader or buyer, consumer visualize what they are purchasing. Let's get into example 2. We have like a student government example. SGA, Student Government Association, is putting on a family event at school. Students and their families will be invited, and the total estimated guests is 440 people. Okay, so I'm going to highlight that information. We have total estimated guests 440 people. The projected ratio of family members to students, okay, so now we have a different ratio here, okay, so we have family members to students is 4 to 1, okay, so 1 is the student and family members is the 4. If SGA needs to make green wristbands for family members, and orange wristbands for students, how many of each colored wristband will SGA need to make? Now, there's a way to do this without ratios. I get that. And you'll probably be more comfortable with that, but I want to show you how to use ratios. That's the whole point. Okay, so the first thing we have to understand is the only piece of given information is this 440. So we need to use that. And what does this 440 mean? This is the total people. Okay, now the ratio they give, okay, let me erase this real fast. The ratio they give does not compare total people. What is the ratio? The ratio they give us, change colors here. The ratio they give us is 4, this is family to student. Okay, notice how total is not referenced in that ratio. So that's not a good thing for us at the moment. What we'll need to do is we'll need to convert this ratio to somehow, or convert multiple ratios to incorporate this total people, okay? So let's visualize this. Let me go ahead and get this set up with the different colors. So let's visualize this. We have 1, 2, I should just copy and paste, but it's too late. I've already started. 1, 2, 3, 4. Okay, so this represents 4 family members, and this represents our little student, okay? Well, it could be a big student. I'm sorry. Our student. Now, for each one of these students that come in, okay, he's coming, he comes to school. He's going to bring 4 family members. Hey, mom, dad, brother, sister, whatever, okay? So we get 4 family members. Now, for each student that comes, what's the total, okay? The total is going to be 5 total people for each student. So what we should do here is we should compare the family members to the total, okay? So then we have family to total people, and we should also create a ratio of student to total people, and I want to emphasize this, it's because we've been given the total amount of people. We haven't been given total students, we haven't been given total family, but we have been given the total amount of people, students and family, okay? Now, what we can say here is if this is a microcosm, if this is a sample of the total that's coming, okay, so the total is 5 people, how many family members are there to the total? Well, there's 4 family members for every 5 total people, okay? So this is the ratio that we are going to use now, this 4 to 5. By the same token, now we have a new ratio for our students. For every 1 student that comes, okay, there's 1 blue student here, we're going to have 5 total people. Before we had 1 student, 4 family members. That doesn't help us because we're not given the number of family members, but we are given the total number of people. And we know that we combine the students and the family to get the total. So we do 1 plus 4 gives us 5, a 1 to 5 ratio for students to total, okay? So now we have much more helpful ratios, okay? Now, what we're going to do is we're going to calculate these green wristbands for the family first. So let's go over here to green wristbands, okay? Here we're going to use our ratios. So we already know that there's 4 family to 5 total people, okay? Now we're going to set it equal to the actual numbers that we have. We know the total people. We know the total people is 440. That's what it gave us at the beginning. Okay, 440 total people, students plus family members. Okay. Now, what we need to know is we need to know how many green wristbands we need. So we need to know how many family members are going to be coming. Okay, that's essentially the problem. How many family members are coming based on this ratio and based on knowing that there's 440 total people that have come. Now, what do? Well, we need to use cross multiplication. This is a great strategy to use anytime you have a proportion. This is an algebra concept. If you need a refresher on this, make sure to check out some of my other videos. But this is cross multiplication. What we do is we do 400. I'm going to draw my equal sign and then my multiplication, just so you can see what I'm doing here. I'm going to be multiplying 440. I want to move that. Sorry. Over here. 440 times the 4 family member ratio, okay, equal to the x, okay, times the 5 total family members. Okay, why can we set these two things equal to each other? We set these two things equal to each other because they are equivalent. We already know that there's 4 to 5 family members, 2 total number of people. So if we know there's 440 total people, this fraction will be the same. That ratio will be the same. So that's why we're able to set this up. Oh, I forgot to write 5. And now we proceed from here. We do 440, sorry, my calculator, 440 times 5, and we get 2,200. So we get 2,200, and it's going to be equal to 5x. So we need to divide by 5 to both sides to solve for x. Once we do that, hold on a moment. We get 440. Oh, times 4. Sorry, I messed up. 440 times 4. I don't know why I multiplied it to 5. We get 1760. I know you guys are probably following along going, what the heck is this guy talking about? Here we go. Now I'm going to divide this number by 5. All right, and we get a much better number. Okay, so we get 352. This means that there's 352 family members, and that's how many green wristbands we're going to have. Okay, so that's green wristbands. Now, you could just take 440 and subtract the green wristbands to find the orange wristbands for students. That'd be a way to do it. So just as a demonstration real quick, we could do 440 minus this, and that would equal the student wristbands or the orange wristbands. Okay, if you want, write that down. I'm about to erase it though. 3, 2, 1, erase. Okay, but I'm going to show you how you can use proportions to solve it. So we have the orange wristbands here. I should have just made it orange from the beginning, but here we are. And then I have 1 over 5 equals, and again, we want to know the orange wristbands. I'm going to make it y this time, over, again, we're going to still use the same 440. There's 440 total people, and we're going to cross multiply. So we cross multiply here, equals times times. We have 1 times that, and we have 5 times that. Okay, it doesn't matter which order you do it in, really, as long as you make sure you multiply the right things. So 1 times 440, 5 times y. So we have 5y equals 440. We divide by 5, divide by 5. 440 divided by 5 equals 88. So we have y equals 88. That means 88 students, aka orange wristbands, and that's what we need to know. Now, that's I don't want to make this video too long, so we'll make this part 1 of this series, and we're going to talk about extended ratios and how to do some of these kind of cross multiplication properties in just a moment. Stay tuned for that. This is really where we get into the math, where you're going to have quiz questions and stuff like that. So stay tuned. Hope you enjoyed this video. Part 2 coming right up after these messages.